Welcome to the HiRSE-Seminar series on research software engineering in Helmholtz and beyond.
All right, so thank you for the introduction. My name is Florian Mannseicher. As Claire said, I work for the Society for Research Software in Germany, the sole employee there as a project coordinator of the FutuRSI project, where we conceptualize a German research software institution. So 6 project partners are involved in the project: the Society for Research Software, the Society for Informatics, the Jülich Research Center, the Helmholtz Center Dresden-Rossendorf, and the University of Jena, as well as the University Library in Göttingen. The project is funded by the Klaus Tschira Foundation. The goal of the project is to develop a concrete concept for a research software institution. And we want to actively shape Germany's future research software ecosystem, and this will involve coordinating and integrating with existing initiatives and structures. But we also aim to raise awareness and advocate with scientific institutions and policymakers, and thus help to shape the cultural change in dealing with research software in Germany at a strategic and organizational level. Now, what general challenges and specific needs do we face? So this content here that I show you is drawn from 18 expert interviews, and details can be found in our key issues paper. The first challenge relates to individuals. The research software is often developed without the necessary expertise or processes. There is a lack of training pathways for research software development, and the roles of those with an academic interest in purely hypothesis-driven work and those involved in the development of research software are often unclear, and more education and training is needed, as well as community services to facilitate knowledge transfer and coordinate access to training resources. The second challenge relates to the structures and mindset surrounding research software engineering. The lack of visibility of career paths and the insufficient recognition of research software engineering and those who develop it makes recruitment difficult. A change in thinking and awareness building is needed to ensure that research software is recognized at all levels as an essential research output, but also real structural adjustments to the system are needed to facilitate career paths for those who develop research software. And taking a bird's eye view of the German science system makes it clear that it's highly diverse. The diversity of the research software ecosystem in Germany also complicates unifying activities and the differentiation from existing initiatives. Now, there's a concrete need for more networking and coordination to organize working groups, disseminate successful practices, and similarly, there is a lack of institutional legitimacy. So no actor has been given a mandate by science policymakers and the research software community alike to gain legitimacy. The fourth challenge focuses on research software as an artifact. Research software can exhibit quality deficits and can be difficult to reuse due to a lack of publication or discoverability, and as well as insufficient maintenance and knowledge of quality assurance mechanisms. Consequently, quality definitions tailored to specific use cases and guidelines on quality assurance are needed. Additionally, a structured governance is required to select important research software packages and promote their long-term maintenance and development. And lastly, national platforms and technical services could be established where appropriate. And the final challenge is for observers of the system who lack a solid research base with a need for research software, with a need for research on research software engineering. Let me talk you through the possible formats and instruments that we are considering to address these challenges. This list that I present to you is by no means exhaustive, and we are currently revising as we're progressing with the project and learning. So we envision the research software institution as a contact point for local research software units to provide process support services, for example, helping with accreditation and consultation. The institution could also offer practical support on documentation, on metadata management, and finding resources, plus also advising on funding or licensing and tech transfer. Additionally, it could provide development support with research software engineering as a service. The research software institution could coordinate existing training offerings through a central overview and build on foundations like the carpentries with specialized courses in application-focused skills and management. And we are also considering structured skills development, like a multi-level certification system from micro-credentials to formal qualifications. The research software institution could include a maintenance fund for research software, or micro grants for small projects, or a rapid response fund for urgent challenges or innovation. And additionally, fellowships or exchange scholarships and transfer grants could support individual development. The career support could include mentoring programs, job services, annual awards, and defining professional pathways for RSEs. Now, community building could happen through regular workshops and forums with professional management of events and newsletters, for example. Crucially, obviously, this requires broadly accepted governance with a clear mandate, reputation, and trust. So the research software institution could identify needs, coordinate advocacy efforts, bring insights together in a central access point. The institution could also bind and maintain strategic partnerships with universities, research institutions, and funding organizations alike to strengthen the entire ecosystem. The research software institution could develop guidelines and checklists for good practices, peer review, and automated quality checks. And technical services could include a research software directory with competency mapping or a central service overview, prioritizing the existing tools and potentially, for example, code repositories. And finally, the research software institution could build a knowledge center, collecting and disseminating information, reporting on project progress, developing position papers. And we also see a value in establishing research on research software as an independent field of research. So you have heard me talking about the research software ecosystem. So let's have a look at what we mean by this term. The research software ecosystem can be understood using an analogy of a natural ecosystem. The ecosystem itself is the dynamic interconnected network of people, institutions, software, infrastructure, practices, and policies that sustain research software. And within this ecosystem, so specific research software infrastructures act as the habitats, the structural environments, both technical and organizational, that provide the conditions for software to be developed, maintained, and reused. And the software and software projects are the species. So tier one is personal or project software that is written by one person for one person or project with little external use. Tier two is community or shared software that has been adopted across multiple projects, showing a growing interest. Tier three is critical or foundational software that is used across institutions and disciplines essential to entire research fields. Now, who shapes this ecosystem? The people, the research software engineers and research software practitioners, they come from different roles, academic, technical, and support staff, and they are united by the shared mission to develop, use, provide, and or maintain research software. And they come together in what I call research software guilds, which are structured groups that bring expertise in areas such as development or training, advocacy, and infrastructure provision. So and these guilds can be embedded within institutions, be cross-institutional, be virtual, or be even temporary, but they all share the same mission goal to strengthen the use of research software in research practice. I will later provide a framework for them to have the home. That's why the looking glass is there. And lastly, governance is the climate shaping the conditions under which the whole ecosystem can flourish, creating a shared vision and accountability and trust. But first, let's turn to 6 key takeaways from looking at 19 institutions that we have directly examined, including the UK SSI, the Netherlands eScience Center, the Digital Research Alliance of Canada, the NHR Alliance in Germany, the German Network for Bioinformatics, DENBI, or the DFN, Deutsches Forschungsnetz, or the Network University Medicine, and many more. So first, governance structure. The takeaway is that a federated model with strong central coordination and local autonomy ensures scalability, legitimacy, and sustainability. And it could be anchored in a trusted legal foundation and a governing body that steward the ecosystem, thus avoiding a complex governance structure and creating clear roles. Second, funding strategy. We should aim for securing also a long-term seed funding to launch, then transition into a diversified, resilient model that balances the public investment with community-driven membership or sponsoring and service-based revenue streams. Third, community engagement. We should embed community co-creation at the heart of the institution through inclusive governance and community feedback loops and structured engagement to build trust and shared ownership. Fourth, infrastructure and sustainability, establishing investments in shared, modular, and interoperable infrastructure that can be adapted across institutions and supported by sustainable funding mechanisms for long-term maintenance. Fifth, career pathways and recognition. Research software practitioners need recognition, as I've already mentioned, and possible solutions include establishing clear dual-track career pathways that recognize both technical and scientific contributions, supported by national frameworks for recognition and advancements. And finally, international collaboration. To boost its credibility and impact, an institution should engage with global networks, align itself with international standards, and also foster the collaboration through joint initiatives and shared events. So let's now explore the three institutional structure options for a German research software institution, each representing a different balance between centralization and decentralization, and each with its own strengths and risks and strategic implications. So option one is what I call the minimal coordination office. So this is a loose, decentralized model where local guilds operate independently with a minimal central coordination. And it's low cost and highly adaptable to regional needs, leveraging existing institutions and fostering a strong local ownership, but it risks fragmentation and duplication and also sustainability issues, especially when key people leave or key institutions leave. It's great for building some trust early on, but hard to scale into a unified national presence. Option two, the German Research Software Network. So this is a federated model with a central hub that coordinates standards, branding, and strategy, while partners deliver services locally. So it strikes a balance between national coherence and regional autonomy, and it is scalable and credible, and has already been proven in models in Germany. And also challenges such as the resource imbalances and the need to balance standardization with regional flexibility exist. So there's this, in my opinion, can be managed through a tailored effective governance. And the third option, what we call German Research Software Center, this is a fully centralized autonomous institution, a national center with its own legal entity and headquarters. This obviously offers strong visibility, fast decision-making, full control over processes and services. However, it incurs high costs and carries a significant risk of resistance from existing institutions, not to mention the potential for bureaucracy. It would only be viable with a substantial long-term funding and political support, which in our opinion is currently not really feasible. So in our opinion, the option two offers the best balance. It's the most realistic and sustainable path forward. It's ambitious enough to have the national impact and flexible enough to grow alongside the ecosystem and based on the realities of the Germany's research system. So now I would like to present a possible organizational and governance structure framework that showcases how this option could be implemented. The framework includes three overlapping aspects. The first one of these is the community foundation, which includes everyone in academia who works with research software to bring in the necessary community input into the overall structure, into the common home, if you will. This includes hypothesis-driven domain researchers, research software engineers, technical staff, and also research support staff, among others. Second are the partners within a network that act as the operational backbone of service providers. This could consist of dedicated research software guilds and organizations with a defined participation structure, offering explicit benefits and obligations to the network partners. And third is the research software artifact and research software infrastructure, which promote research software excellence. This structured field of activity enables others to build and maintain the software, and it provides essential funding mechanisms for software as an artifact, as well as the technical and organizational services and resources needed to make the ecosystem function effectively. So now at the center is what I call the Nexus, a central federally mandated coordination hub and one-stop shop for national level coordination on research software. It could connect and support thematic and domain networks, provide advocacy, and enable the delivery of key services and activities across the ecosystem. It could also provide tailored funding and grant programs. So the central nexus could facilitate cooperation through the events and task forces and forums. And it could also provide knowledge resources, for example, and advocate for cultural and structural changes in research performing organizations. Now, governance includes principles and legal foundations. So participatory governance structures and statutes could ensure that every activity aligns to the core values. For example, the nexus would only act at the national level where local or regional efforts cannot achieve the required coordination and standardization or advocacy impact on their own independently. And the network, on the other hand, could operate on the principle that local research software units are best placed to deliver services within their institutional and disciplinary contexts. And now lastly, a steward role could be fulfilled by a steward board or boards. So this would involve providing strategic guidance and ensuring that all components remain principled, as well as offering a strategic advice on the organization's development. For instance, it could ensure that Nexus advocacy reflects the core values, or that infrastructure is supported by network partners, and that activities contribute to the ecosystem as the whole. So at the moment, we are around 30 months into the project year, into the 3-year project. See the HiRSE-Seminar here marked. Just a quick look back. So we have interviewed over 20 experts on various topics and launched a survey to collect information on research software services and groups. And we have also analyzed similar institutions, both nationally and internationally, as I've already reported on. We have published 3 working papers already. So these are linked on the last slide, so feel free to check them out later. And in the second project year, we will conduct a feasibility study and a thorough risk assessment and mitigation strategy. And we have also set up participation formats on the HiRSE Plus platform, which we intend to utilize heavily from now on. And we are already planning on next events, such as the collaborations workshop that will be held in September this year in Göttingen. So we're confident that after more refinement and after 3 years, we will have developed a concept supported by all key stakeholders, and that we can directly go into implementation of the institution. So this is our project team. It's a large team distributed across Germany. We are working fully virtually with in-person meetings, so around every 6 months. So if you have questions about the project or feedback for us, so please feel free to contact the colleagues named here. And if you want to find out more about FutuRSI, please take a look at our website, GitLab, or social media channels, including Mastodon, Blue Sky, or LinkedIn. You could also read through our publications on Zenodo, and if you would like to play a more active role in shaping the future institution's design, please consider becoming an official supporter and also a community sounding board member if you like. Links you can find on the website. Also, keep an eye out for our participation formats using HiRSE Plus that we announce via our channels. So be sure to follow us on the platform of your choice. And with this, I thank you, and I will be happy to answer questions.
Thank you for watching our seminar. Please check out the slides on Zenodo linked below, and see you next time.